Okay, so I am doing number 18 and we're revolving this around the y-axis. So we're using the second of the two formulas, the number 4 on page 334. So there's not really any major difference between them. It's just whether you're using x or y. So if this wasn't solved for x, you would need to solve it for x because you're doing it around the y-axis. Now the book and the problems are pretty good about giving it to you in terms of one or the other. But that's really the main difference. If, for instance, I want to take this exact same equation and revolve it around the x, I would first need to solve it for y. But luckily, we don't have to do that. The first thing I want to do is I want to find the derivative here, so x prime. So 1/3 times, bring down this, subtract 1. Over here, bring down, subtract 1. So those cancel, and I have y to the 1/2 over 2 minus 1 over 2 y to the 1/2. Or if you're used to thinking about it in terms of square roots, these are square roots. Okay? Then I need to put this into the inside of that radical. I need to do some simplification here to make this more manageable. So this is this, and I like thinking about the radicals here. And this is squared, so remember this is going to be FOIL. There is no shortcut here, despite what all my college algebra students like to think. And unfortunately, I know you guys can be drawn into those same mistakes, so make sure you're actually foiling this out. So 1 plus this first one is going to be y to the 4th. And then I'm going to get 2 middles, so I'm going to have 2 square roots of y over 4 square root of y plus 1 over 4y. So then these will cancel, and I'm left with this is 1/2. Add it to that, so that's 1/2 plus y to the 4th, y divided by 4 plus 1 over 4y. And make sure you keep those y's where you can see them so you know where they're going. Okay, now I'm going to put this all into the integral. So I want to go from 1 to 3, 2 pi. I put my original equation. So I'm going to go back up here, and I need to use this, remember? So I have 1/3 y to 3/2 minus, what do I got? Minus y to the 1/4 times the radical of all of this. And then this is dy. Now you're probably thinking, I don't know what to do with that. Well, this is an algebra trick. And remember I said in this note section that there's going to be a bunch of algebra tricks here. So right now I'm just copying these. This here, so I'm going to pull this out for a minute. So this is y. So what I'm going to first do, I'm going to do 1/4 y plus 1/2 plus 1/4 over 1y. So I'm going to pull out a 1/4 first. This is going to be y plus 2. Do the division here if you don't believe me on that, but I promise you it works, plus 1 over y. Now normally if you would factor, you would start with the squared, right? We're not, so we're going back. So this actually factors to this. And really what this is an extrapolation of that special binomial. Remember back in algebra when you learned, and there was a bunch of formulas you knew that we went over that were special formulas on like perfect square binomials. This is a perfect square binomial, and this is what it does. And you can go back to those formulas back from like intermediate algebra, and that's where this comes in. But that's how we get this to work. So this is what's under the radical here. Why is that important? Well, because I can actually take the radical of that. So this is 1/3, 2 pi. No, that doesn't look like 2 pi, does it? I've copied this so many times, you'd think I'd have it memorized. No. Okay, and then this is 1/2, and this is square root of y plus 1 over square root of y dy. Okay, we're getting somewhere. Now I'm going to FOIL again. 1/3. Okay, so these and these cancel out. I just have a pi. And I'm going to FOIL these two. So this is to the 1/2, right? So this is 1/3 y. Well, we add them, so that really becomes a 2, right? 3/2 plus 1/2 is 4/2, which is 2. This is exponent rules. Again, we're back in intermediate algebra. Okay, so these two, that's going to become y, right? 1/2 y, square root of y times square root of y, which just goes away. So that's my inner. Then I'm going to do my outer. Did my FOIL out of order. Let's see here. This is quotient rule. I'm subtracting, right? And I'm left with 1y because I have 3/2 minus 1/2, which is 2 over 2, which is 2. And finally, this last one, okay, that's going to become, this is just going to become 1. Ooh, that, like, okay, and don't forget my dy. I'm carrying it along. Okay, 1 to the 3 pi. Let's see here what I can do here. I have 1/3 y squared. Oh, well, this is 2/3 y minus 1 dy. Okay, I can take the integral of this now. That was a page of algebra to get here. Calculus isn't hard. The algebra is killer. Okay? So, now at this point, carrying this pi along, let's see here. Add 1. So that's going to be 1/9 y to the 3rd minus, okay, that's going to be 2, so 1/2, so 2/6, so 1/3 y squared minus, let's see here, y evaluated from 1 to 3. Okay, this doesn't seem so bad. So pi, and do this out here so I don't have to do this here. So in here I have 1/3 times 3 to the 3rd is 27 minus 1/3 times 9 minus 3 minus, okay, and then the whole big second half, 1/9 minus 1/3 minus 1. Okay, now I'll get out my calculator, do some number crunching. So I'm going to do the inside and just at the end I times it by pi. So I have 27 ninths. Keep them in the right order. Minus, that's 3, minus another 3. So this is pi negative 3 minus, okay, 1/9 minus 1/3 minus 1 equals minus 11/9. So add those together, 11 minus 3. Let's see what I got here. 8 pi over 9. And hold on a second. I'm checking my math here. So 27/9 minus 3 minus 3. 1/9 minus 1/3 minus 1. Oh, right here. 11/9 minus 3. Aha. Okay, 16/9 pi. I'm like, that shouldn't be. Looking at my answer, I'm like, I'm supposed to have 16/9. And I'm checking. Looking to see if I lost a sign here. Okay. Well, it's supposed to be 16/9 here, right here. So that seems like a lot of algebra to get here. So as a note, I want you to pay attention, though, to this trick right here that I did because you are going to need this on one of the homework problems.